Welcome to another exciting educational video brought to you by Vision Concept Academy. So in this video, we'll be looking at mensuration, past questions in NECO, WAEC, and JAMB. We'll comb through some of the past questions related to mensuration, and we'll be solving them. There's a playlist in our channel that treats past questions from specific topics that accumulates to JAMB. So sit tight and enjoy the video. If you're not subscribed, subscribe to our channel to get more videos. So right away, we have the first question on the board. This question is taken from 1991 WAEC. It says, in the diagram, PXR, that's PXR, and PYO, that is PYO, are two semicircles with diameters 14 and 70 m respectively. So this PXR, the diameter is 7, 14. Obviously, they are giving us this dimension as 7 because the dimension is between the center of the big circle to the exterior. So it means that this side to this side is also another 7. That is making it 14. Though in the diagram they did not put the 7 here, so at least you will know that from P to R is a complete diameter, and from O to R is half of the diameter. So if 0 to O to R is 7, then P to R will be 14. So find the perimeter of the region. Now perimeter is defined as the measurement of the exterior of the shape. So I'm going to start from this place, and I'll measure to this point, and to this point. So how do I measure to this point? That's all round. I'll first of all identify 3 distinct shapes. There is a semicircle or half circle PXR. PXR is half circle. So I'm going to find the diameter, the circumference of this, plus another semicircle PYO, that is this one, and 7, that is OR. Let me just go ahead of myself. So there are 3 different components of this shape. So if you have a complex shape or a not so regular shape that you don't expressly know the perimeter formula or area formula, as the case may be, break it down into recognizable shapes with distinct formulas for calculating either the area or the perimeter, as the case may be. We're looking at perimeter this time around. So like I said from this shape as it is, I can identify 3 component shape. The first shape is PXR, which is this one. PXR will give me a semicircle. And you know the perimeter of a circle is 2 pi r. That's the perimeter of the circle. But if I were to write the perimeter of half of a circle, I will also include times half. So this one is the dimension or the perimeter for the PXR semicircle, plus I have PYO. PYO is another semicircle that is inverted on top to join this other one, and the circumference again is half of 2 pi r. Okay, then OR is OR, and it's just a simple line from 0 O to R. So I can just put the dimension there, 7. So I've broken it down. So from here on, I can now quickly solve. So what I have done now is my test of identifying the kind of shape it is. Okay, I'm tested on how to identify the kind of shape. So you write outside, say there are three distinct shapes. If you are doing it as a theory, say there are 3 distinct shapes. You name them. This one is half the bigger semicircle. This one is smaller semicircle, and from here to here is a straight line. They are all joined together. So the 3 of them combined will give me the circumference of the full shape. So for this first one, if 2 cancels 2, I'll be having pi r, plus 2 cancels 2 again, having pi r plus 7. This first pi r is pi r of PXR. PXR, the radius is going to be 7. Why? Because PR is already 14. So half of PR is 7. So I'll put my pi, 22 over 7 times 7, plus here again 22 over 7 times the radius for the small semicircle is supposed to be 3.5. Why? Because the diameter of this one circle is 7. So half of 7 is 3.5. So I have here 3.5 plus then 7. So you see, I'm still in line with the 3 components. So 7 will cancel 7. I have 22 here plus. Now this one is this here 1, this here 2. Why? Because 7 can divide 3.5 2 times. Okay, so 2 here 1, 2 here 11. So this side I have 11 plus 7. By the time I add everything together, I'll be getting 40 cm. So you know it's length we're looking at, the length of the shape. So it's not going to be a square, so it's going to be 40 cm. Okay, so go to the next question. Okay, so we have another question on the board. It says a cylindrical pipe 50 meter long with radius 7 meter has one end open, yes. What is the total surface area of the pipe? So this JAMB question 2010. So these are the options. So I'm going to solve to see which one is correct. So this is a cylindrical pipe that looks like this. So they said one end is open, so I will not enclose it here. So this end is closed. This is the cylinder. This one formed a curved shape around it, and this one is the closed end. So what is the total surface area? So the total surface area has 2 components. Total surface area, again, total surface area of this cylindrical pipe is equals to the area of the curved base, area of the circular base, circular base, which is this one, plus the curved surface area, this side, the curved surface area. Okay, so now I can quickly write it. Area of the circular base is pi r square plus area of this curved side will give me 2 pi r h. You know this 2 pi r, there is the component of the circumference and the component of the height. You understand? To form area like this. This is like a length times breadth. This is like the length. You know, length is circumference. So for circle, it's the length times the breadth. It still comes from the basic definition of length and breadth times breadth to give us area. So having gotten this formula, we can now start putting what we have. Okay, I think all the answers are expressed as pi. So I won't touch anything pi. I'll just leave pi. So I'll say pi outside times the radius. What's the radius of the cylinder? The radius of the cylinder is 7 meter. Okay, so I'll put it 7 square plus 2 pi. Then the other one, I will convert this one to meter, right? I'll convert it to meter. So I will say 2 pi, then R is 50. Okay, sorry, 7. This is 7. Then the height is 50. Like this, 50. Okay, so we'll proceed. Okay, so we'll proceed. So I've just been told that this is meters, not centimeters. So I'm correct here. So we'll proceed. We'll now say 49. This is 7 squared is 49. So 9 pi plus then 2 times 50 is 10. Then, sorry, 2 times 50 is 100. 100 times 7 is 700. 700 pi. By the time I add it, I'll be getting 749 pi meter square. So the answer should be A. So A is correct in this case. So we'll go to the next question. Okay, so I have this question on the board. It says, in parallelogram PQRS, this is parallelogram here, PQRS, all right? PE, this is PE, is perpendicular, this side is perpendicular to QR, that's QR. Okay, so perpendicular means that this line PE is meeting this QR at 90 degrees. That's why I'm having this 90 degree sign here, 90 degree indication here. So if base QR, where's QR? QR is 12, and PE, where's PE? And PE is 5 cm. Find and QE, not PE, and QE, that's QE is 5 cm. Find the area, right? So these are the options. Okay, note that the area of the parallelogram, note area of parallelogram, parallelogram is equals to base times height. In this case, base is QR, and height is PE. Okay, so this is a line, this is a line. So QR is this, QR, that's the base, and PE is this one. All right, so but we have QR. QR is a summation of 5 and 7, which is 12. It's already given as 12, so we know that. But this is given to us so that we can define PE. You know, PQE forms a rectangle triangle. So we can use the Pythagoras theorem rule to get this line. Okay, so we can get PE. QR is known as 12. Okay, so if QR is equals to 12 cm, therefore PE line will be, using Pythagoras theorem, will be square roots of the sum of 12 square plus 5 square. All right, so I have it as square root of 144 plus 25, which is going to give me, how do we add this? This and this will give me 9. This and this will give me 6 and 1. Okay? Yeah? Okay, so I'm going to be getting 13. Now the square root of 169 will be 13. Okay, so we'll take it step by step. So this is the PE we're looking for. Understand? And if I do the triangle PQE, let me bring it out. This is PQE. I'm looking for PE, right? If this is 12 and this is 5, what is PE? You know PE square, let me use PE as x. So x square plus 5 square is equals to 12 square, and x square is equals to 12 square minus 5 square, right? So x is equals to root of 144 minus 25. That's why I'm having it here. Because I was putting plus here, but it's supposed to be minus. So by the time I do the difference, I'll be getting square root of 119, and which is approximately 11. Upon approximation is 11. Okay, will be 11 cm. Approximation is like 10.9, which is 11. Now I haven't gotten PE. I can put it in this formula because area of parallelogram is base times height. I already gotten my base as 12. Q arrow is 12. So I will say area of parallelogram is equals to 12 times 11. It will give me 132 cm. 132 cm what? Square. So the option is D option. Okay, we'll go to the next question. So I have this question on the board, number 4 question. It says that find the side length of a rhombus whose diagonals are 6 cm and 8 cm. This is JAMB 1990. First of all, what is a rhombus? A rhombus looks like this. That's how a rhombus looks like. So we're trying to find the sides of a rhombus whose diagonals. So I have this diagonal here and this diagonal here, whose diagonals are 6 cm and 8 cm. So this first diagonal is 8 cm. And you know the diagonals cut each other at equal half, at half. That's cut, bisect, that's the word, bisect each other at the center. Okay, so if this line, this first line is 8 cm, it means that from this point to this point is 4 cm, and the second side is 4 cm. And if this from here to here is 6 cm, it means that from this center point to this exterior is 3 cm, and this is 3 cm. So in effect, I'm having 4 right angle triangles inside this shape. 4 right angle triangles, because the properties, you need to know the properties of these shapes. The rhombus property is that the diagonals bisect each other at 90 degrees and at the center into half. You understand? So I'm having a right angle triangle here. So this one and this one are the same, and this one are the same, and this one are the same. So I can pick one of them to get this side. If I get this side, that means I'm getting all the sides, because it's going to be the same thing. You understand? So I'm picking this one. So applying Pythagoras theorem to, let me label it. Let me call this one A, B, C, D, and center is E. Let me put center E. So considering triangle A, E, B, which is AEB, this one. Understand? So we're going to apply Pythagoras to get AB, right? Comma, then apply Pythagoras to get AB. Okay? So I'll write out the Pythagoras formula, or yes, expression. AB square line is equals to AE square plus EB square. So this is the expression. I'm looking for this one, right? So AB square is equals to AE is given as 4 square plus EB is given as 3 square. So AB line square is equals to 4 times 4 is 16 plus 9. So AB line will now become the square root of the sum of these two, which is 25. So this line AB, which is a side of the rhombus, is 5. So another thing you need to know, 5 cm, and 5 cm is B. What you need to know is how to even write Pythagoras triple. That's there's a set of 3's. Understand? So I have a triple like this, 3, 4, 5. Meaning that if this side is a one of the side is 3, the other side is 4, the longest side will be 5. So there's a tripling that we need to know. Okay, well, that's by the way. Let's go into the next question. So I have this question on the board. It says find the volume of frustum of cone with lower radius 10 cm and upper radius 6 cm and height 9 cm. So this is a frustum. This is a frustum. A frustum is actually derived from a cone like this. So if I continue these 2 points, they will meet at a point. So this exterior is the cone, but the smaller cone is cut off. So this other side is the frustum. So I have the frustum. This is what I'm looking for, the volume of the frustum of a cone, and the lower radius is 10 cm. The upper radius is 6 cm. So this is this one that is 6 cm. Radius is from the center to this point. So I have this one as 6 cm. I have this one as 10 cm. So their centers will meet and form a height of 9 cm. Now, there is a direct formula method. Normally, you can also use the indirect method where you can just find the volume of the bigger cone, you understand, and the volume of the smaller cone, which is this one, then get the difference. So the bigger cone volume minus smaller cone volume will give me the volume of this cone. I'm going to use the direct method where the formula is V, volume of cone, of frustum, is equals to half pi h, open bracket, I'll have R1 square plus R2 square plus R1, R2. Then close my brackets. Okay, so I will define it where R1 is equals to the radius of the smaller circle. That's this one. The radius, sorry, of the lower one. Any one, but just know what you are doing. The radius of the lower one. Radius of the lower circle or larger circle. So I will say larger radius. This case, R1 is 10 cm, right? Then R2 is smaller radius, that's the upper radius. And this case, R2 is 6 cm. Then, of course, I have height h. Height h, yes, there's height h here. Height is equals to, what's our height again? Our height is 9 cm. So having these parameters, I can plug into this formula. I'll say 1/3. Volume is 1/3 times pi times height is 9. I'll put my 9 there. Open brackets. Then R1 is 10 square. That's R1 square plus R2 square is 6 square plus 10 times 6. 10 times 6. Okay, let me put times here. Close the bracket. So from here on, I begin to solve. This will cancel this. I have 3 pi, open bracket, 100 plus 36 plus 60. Okay, so when I do that, I'll be getting the volume is equals to 3 pi times, by the time I sum all this, I'll be getting 196, and the volume expressed in terms of pi will be 588 pi cm cube. So this is how to go about it. So I'm going to be leaving the following questions in the description from number 6 to number 10 with the solved solution, and also the comment section. If you're not subscribed to our channel, kindly subscribe to our channel to get more videos on the STEMs, maths, physics, chemistry, and biology. So I hope this video has been useful for you. I'd like to thank you for viewing.